Okay, in this video, I'm going to show you what an energy distribution curve is, or an energy distribution diagram. So, as with any diagram, we start with our y and x axis. And in this one, our x-axis is going to be our energy, and our y-axis is going to be our number of particles or molecules. Okay, so I can just kind of draw any curve I want. Make my x-axis go a little farther. So what an energy distribution curve is it sort of takes a snapshot of the molecules in your reaction at any given time, and it shows us what the energy is for the molecules involved in our reaction. And on this energy distribution curve, we can actually plot our activation energy. So if this was my activation energy, this means that all of the molecules on this side of the activation energy have an energy higher than the activation energy. So they're going to give us successful collisions, whereas all of the molecules on this side of the graph don't yet have quite enough energy to produce successful reactions because their energy is less than the activation energy. So now let's say I add a catalyst to this reaction. That's actually going to move my activation energy or lower my activation energy. So this is my activation energy with a catalyst. And now all of these particles now have the necessary energy to have successful collisions in our reaction. So if I add a catalyst, it's going to lower my activation energy and move that activation energy to the left, meaning that more molecules have the appropriate energy for successful collisions. All right, so let's actually give that slide and start over. So one other thing that I want to show you with this energy distribution diagram is if I have my x and y axis. So again, this is energy, number of molecules. So I have this graph for one of my reactions, and it has a certain temperature. So we'll call this A, and it has a certain temperature. Then I do the exact same reaction, but at a different temperature, and I get this reaction. So now, and we'll say that my activation energy is right about here. Oops, and we'll call this reaction B. Well, which one of these reactions is likely at a higher temperature, A or B? Well, what we have to look at is the number of molecules in each of the reactions that are above the activation energy. In reaction A, I only have this many molecules at an energy above the activation energy, so those that are going to produce successful reactions. But in reaction B, and again, same reaction, just different temperature, all of these molecules are going to be at the appropriate or required energy above our activation energy to accomplish or produce successful collisions. So from this graph, I can infer that B has the higher temperature because it has more molecules above the activation energy, whereas A has fewer molecules above the activation energy. So it likely has a cooler temperature. So that's just one other way that you can use these energy distribution diagrams.